In this video, we will learn how to write an assembly language program to convert our hexadecimal number to BCD number. So here we have taken in this program that is dot model small. So it indicates that our program, that is our data segment and our code segment, are stored within only one program segment. In this data segment, we have declared one hexadecimal number and the value for this hexadecimal number is 0ACH. We have taken the counter value is equal to initially 0. In this code segment, we have to initialize this data segment. That's why we have to write these two statements, that is move AX @data and move DS, AX. So the address of your data segment will be copied it into AX register and values of the AX will be copied it into the data segment register. Now see, we are executing this program in single step of mode of execution. Then first of all, we are redirecting to the move AX @data line. After executing this statement, the address of the AX register will be updated with 0710, that is the address of our data segment. Now we have to assign the address of our physical data segment, that is @data, to our logical data segment, that is DS. Previously, in the DS segment, that is data segment, the values are 0700. After executing this statement, it will become 0710. Now our control is redirect to the next line of our code, that is move AX, hexadecimal. So our hexadecimal value consists of 0AC, that is AC. That value will be updated in our AX register and our contents of AX becomes 00AC. So our AH consists of 00 and our AL consists of AC. Now we are copying the values of our 000AH into our BX register. So after executing this instruction, our value of BX becomes 000AH. Now we are redirecting to the our label, that is L colon, and we have written this group of statement in our label. Till jump L instruction, our label will be executed. Here, the values of our variables will be displayed, that is hexadecimal is equal to 00ACH and counter is equal to 00H. There is option for variable here. After clicking this option, our variables will be displayed, that is the value will be displayed on that variable. So previously the counter is equal to 00. Once we are clicking on that single step mode of operation, then our counter will be updated with 1 and it will become 01H. Now we are at division BX instructions. So before that, check what are the contents of that AX and BX register. Our values of AX is equal to 00ACH and value of BX is equal to 000AH. And our instruction is division BX. Now let's see how this instruction will be executed. Now see how this division instruction will be executed. Our instruction is division BX and our value of our source is equal to BX register. So BX is our source. So how this operation will be executed? This will be executed as AX is equal to AX divided by BX and DX is equal to AX mod BX. So our value of our quotient will be stored into AX register and our remainder will be stored into DX register. So after performing the division instruction, each time our quotient is stored in AX register and our remainder is stored in DX register if we are performing the division of 16-bit number. So here our BX is, our source is 16-bit number. That's why our quotient and remainder will be stored into AX and DX register respectively. Now what are the contents of our AX and BX register? Our AX is equal to ACH. and our bx is equal to a. So after performing the division operation, our value becomes AC divided by A, and our value of AC divided by A is equal to 11, and AC mod A is equal to 02. If you are performing this operation on the calculator, you will get this value, that is 11 and 02. So now what is the next instruction? The next instruction is push dx. So our dx consists of now 02. So this value will be stored it into stack. So this is our stack, and it will store the values that is going from this dx register. Now currently our dx register consists of value is equal to 02. So it will store stack value dx is equal to 02. Now what is the next instruction? That is compare instruction. Compare ax comma 0. So after writing this instruction, that is compare ax comma 0, what is the value of our ax? Our value of ax is equal to 11. So 11 comma 0. Now we have to compare 11 and 0. So in this example, our destination is 11 and our source is 0. And when we are comparing the destination and source, that time we have to check if the three conditions. The first condition is destination is greater than source. The second condition is source is greater than destination. And the third condition is we have to check if both are equal. So here our first condition is satisfied. That is, our destination is greater than source. So that means our 11 is greater than 0. If the 11 is greater than 0, then our flag will be set as carry flag is equal to 0. Then our 0 flag is also equal to 0. And our sign flag is also equal to 0. Now the next instruction is move dx comma 00h. Previously we have stored dx is equal to 02h. So we have to clear now dx register. So that's why we have written this statement move dx comma 00h. So now our dx becomes 00. After that our next statement is jump if equal, then go to exit label. So this is the jumping instruction, and they are checking that jump if equal. And here we have to check if our 0 flag is equal to 1, then we will go to the exit label. So whenever we have executed our compare instruction, that time our 0 flag will be set to 0. It is not 1. So here our 0 flag value is not equal to 1. It is equal to 0. So we are not redirecting to the exit label. We are moving to the next statement, that is jump label. So what this instruction can do? It will directly move your control to again this label, that is L colon. And again we are executing that statement for executing our next pass. So what this instruction can do? Previously, our value of our counter is equal to 1. Whenever we have to divide our instruction, that is ax divided by bx, that time our ax is equal to ac and our bx is equal to a. That time our counter value is equal to 1. Now, after executing this increment counter, our counter becomes 2. Now, what is the next statement? Division bx. So, after executing this division bx instruction, we are again executing this one, and we will get the values, that is our ax becomes 11 and our dx becomes 02 in the previous step. Now we are putting that value into our next pass. That is our ax is equal to 11 and bx is that is common, that is a. So we are dividing it as 11 divided by a and 11 mod a. After dividing this instruction, we will get the value that is 11 divided by a is equal to 1 and 11 mod a is equal to 07. This is your 01 and this is your 07. So our value of our quotient is equal to 01 and that is store it into AX register and our remainder is equal to 07 and that is store it into DX register. Now what is the next statement? That is push DX. So whatever the data will be stored it into the DX register that we are moving it into stack. So here 07 will be stored. Now we have to compare ax comma 0. So here we after comparing these ax comma 0, we are writing it as compare ax comma 0. So we are comparing ax comma 0 that is 01 comma 00. So here what is our destination and what is our source? This is our destination and this is our source. Here also this condition will be satisfied, that is destination is greater than source. And if our destination is greater than source, then our carry flag will be set to 0. Then our 0 flag will also set to 0 and our sign flag is also set to 0. So now in this program, the next statement is move dx comma 00h. So again we are clearing this dx is equal to 00 because previously our dx becomes 07 after performing the division operation. Then now we are clearing this dx is equal to 0. Now what is the next statement? Jump if equal, then go to exit level. So in that jump if equal, we are checking the value of our 0 flag. If it is 1, then we are redirecting to the exit label. But this is not equal to 1. After executing this compare instruction, our 0 flag is equal to 0. So we are not moving to the exit label. We are going to the jump L label. And this data will be again here and our execution of our increment instruction will be executed. Increment counter is instruction there in our label and after executing this instruction increment counter, our counter value becomes 3 because previously it is 2. So after executing this it will become 3. Now again we have to execute this division instruction, that is division bx. So our bx is common, bx is equal to a. Our values of ax will be updated and we have to put the updated value into our ax register. So again we have to execute this pass, that is division bx instruction. So after executing this instruction, we will check now what are the contents of now ax and bx. So previously, what is the contents in our AX register, that is 01. So put that 01 value into our AX register. So now 01 divided by A is equal to 0 and 01 mod A is equal to 1. So now we got the values of our quotient and remainder. So quotient is equal to 0 and remainder is equal to 1. Now we have to push our value of our dx into our stack. So what is the value of our dx? That is 01. So we are copying this value into our stack. Now our stack becomes 01, 07 and 02. So what is the next instruction now? Compare ax comma 0. So in that compare x comma 0, value of our ax is equal to 0. And we have to compare this 0 is equal to 0. So when we are comparing these two values, here our destination is equal to source. When our destination is equal to our source, that time our 0 flag is set to 1, our carry flag is set to 0, and our sign flag is set to 0. So here our 0 flag is set to 1. And our next instruction is move dx comma 00x. So we are setting our value of our dx is equal to now 0, 0. Again, we have to go with the next instruction, that is jump if equal, then go to exit level. So jump if equal, what this instruction can do? This instruction will check if our 0 flag is set to 1, then our control will be redirect to the exit label. And here our 0 flag is set to 1 because source and destination, these two values are 0 and 0. This is equal. Then we will directly redirect to the exit label. We are not going with the jump label, that is L label. We are directly move to the exit label. And next part of our instruction will be executed. But before that, we will see these three passes, that is counter 1, counter 2 and counter 3, how it will be updated in our emulator. That we will check in our emulator screen. Then we will go with the next part of our execution of our program. See, now our counter value is equal to 1 in our emulator. Now we are redirecting to the division BX instruction. So here our AX consists of AC and our BX consists of 0A. After executing this division BX, our value becomes AX divided by BX, and our quotient is stored in our accumulator, that is AX register, and our remainder is stored into DX register. So now our AX is equal to 11 and our DX is equal to 02. Our next instruction is push DX. So our whatever the value will be there in our DX register, that will be stored it into our stack, and our DX register becomes 02. So 02 value will be moved into the stack. Now next one, we have to redirect to the next line of our code, that is compare x comma 0. So our value of x is equal to 11 and we are comparing this 11 with 0. So our destination is 11 and our source is 0. So after comparing this 11 and 0, our destination is greater than 0. So our all the flags, that is 0 flag, sign flag and carry flag, will set to 0. Then move dx 00h. Now our dx is equal to 0002h. So after putting dx is equal to 00, it will reset it as 0000. Now our next instruction is jump if equal, then go to exit level. So here we are redirecting to the jump L instruction because our 0 flag is not equal to 1. If our 0 flag is equal to 1, then we are redirecting to the exit label. But here our 0 flag is equal to 0. So we are redirecting to the jump label. So after executing this instruction in single step mode, it is again redirect to the increment counter instruction. So after executing this increment counter instruction, our counter value becomes 02. Now again we are redirecting to the division BX instruction. So after executing this division BX instruction, it will divide it as AX is equal to AX divided by BX and DX is equal to AX mod AX. So our quotient will be stored it into our AX register and this remainder will be stored it into our DX register. So our AX becomes 01H and our DX becomes 07H. Now again it will be redirect to the push DX instruction. So whatever the contents are there in the DX register, that will be updated here in our stack. So our now contents of DX is equal to 0, 7, and previously our contents of stack are 0, 0, 0, 2, and we are adding into our stack, that is 0, 0, 0, 7. So see here, previously the contents of stack are 0, 0, 0, 2, and now we are adding here 0, 0, 0, 7. So it will be pointed as a last value, that is we have pushed into the stack. Now the next instruction is compare AX comma 0. So our AX becomes 0, 1. So we are comparing this 0, 1 with 0, 0. So after comparing this AX with 0 value, that is 0, 1 with 0, our all flags will be again set to 0, that is 0 flag, sign flag and carry flag. Now we are redirecting to the move dx comma 0, 0, h. So our dx becomes here 0, 0, 0, 0. Again, we have to check jump if equal, then go to exit level. In this compare instruction, we have set all the flags, that is 0 flag, sign flag and carry flag to 0. That's why here in case of jump equal instruction, we are checking our 0 flag is equal to 1. So here our 0 flag is not equal to 1, it is 0. So we are not going with the exit label. We are again redirecting to the jump label instruction. So we are clicking on that single step mode of operation. It will be again redirect to the increment counter instruction. So check that our counter is equal to previously 0, 2. We are executing this one and it will become 0, 3. It will be updated, it will be incremented with value 1 and it becomes 0, 3. Again, we have to perform this division BX instruction. So after performing this instruction, AX is equal to our AX divided by BX, that is 0, 1 divided by A. It will become 0, 0 in AX register, that is our quotient is equal to 0, 0 and our remainder becomes DX is equal to 0, 1. Now we have to push this DX register into our stack with the help of this push instruction. So we are clicking on that single step mode of operation and we will see the contents of our stack. So the first one, our stack is equal to 0, 0, 0, 2, then 0, 0, 0, 7, and now it will be pointed into the 0, 0, 0, 1. Now check that our compare instruction. So in case of compare instruction, we are comparing this AX comma 0. So now our compare instruction says that our destination is equal to AX and our source is equal to 0. Now our AX consists of all these 0 and our source is also 0. So 0 equal to 0. After comparing this instruction, our destination is equal to source. If your destination and your source values are equal, then our 0 flag is set to 1 and our carry flag and our sign flag is set to 0. So now our next instruction is move dx comma 0, 0, h. So we are clearing here our 0 dx register is equal to 0, 0, 0, 0. Now the next instruction is jump if equal, then go to exit level. Here in compare instruction, we are checking the AX comma 0. So our AX is equal to also 0 and our 0 is also value is 0. So both the values are equal, that is 0, 0. So now our destination and source is equal to 0, that is equal. So in that case, our 0 flag is set to 1. In case of jump equal instruction, our 0 flag is set to 1, then it will be redirect to again this exit label. So it will not going with the jump label instruction. Now check that and clicking on that single step mode of execution, it will be redirect to the exit label of our instruction. So in case of exit label, our instruction is move CL comma counter. Now what is the value of our counter? It is 0, 3, that is last it is updated 0, 3 and we have to move that value into our CL register. So what is the contents of now CL? That is 0, 0, that is 41 is there. And after executing this one, it will update it as 0, 3. Now we have to clear that CH register to 0, 0. So that's why we have write the statement move CH comma 0, 0, H. Then this instruction will be redirected to the next line of our code that is in the L1 label, and our instruction is pop dx. So what is this pop instruction? It will move out one by one data, that is values, from the stack. So first of all, our stack will be pointed to the 0001 value. So it will be redirecting as 0001, and after executing this pop dx instruction, it will pop out our pop out our 001 value, and it will be store it into our dx register. So previously our dx register is 0000. Once we are going with the single step mode of execution, our dx becomes 0001. Now we have to print that output. So how it will be printed? We have to add the 30 into our DL register. This 01 will not be printed on your screen. For that purpose, we have to add the 30 in our DX register. So after adding the 30, it will become 31. Now with the help of 02H interrupt, we are printing that value on your console. For that purpose, we have to move this 02 value into our AH register. So it can say that as a DOS interrupt, and it will inform the assembler that you have to print whatever the value is there in that DX register that will be printed on your console. So our DX register consists of 0031, and once we are executing with that instruction integer 21H, it will be displayed on your console. Now we have display 1 on our screen. Same as like that, we have to display all these numbers. That is our output we have to print on your console. So what we can do? Again, we are redirecting to the next line of our instruction, that is loop L1 instruction. So how this instruction will be executed? In that loop L1 instruction, we have to check value of our counter. And in case of counter, value is equal to 3. Once we are executing with this loop L1 instruction, this counter value will be decremented by 1, and it will become 0, 2. So here our counter is equal to variable is equal to 3. We have to check the contents of CL register in case of counter. So here check that our CX register becomes 0002. So our counter is updated with 02. So it is decremented by 1. In case of loop instruction, if our counter is not equal to 0, then we will redirect to the again L1 label. So again we are with the L1 label, and this label consists of some statements, that is pop dx instruction. So check that in the stack we are pointing to the variable value, that is 0007, and our dx register consists of 0031. After executing this instruction, our 007 will be coming to the dx register, that is 0007. Our dx is equal to 0007. So again we have to print this 7 into our console. So what we can do? We are adding this DL comma 30H. So it will become 37, and with the help of move H comma 02H interrupt and integer 21H interrupt, we are printing this 7 value on your console. So previously check that in our DX register consists of 37, that is the hexadecimal value of our 7. So we are taking the hexadecimal value into our DX register, and with the help of DOS interrupt 02H interrupt, we are printing the data on your console. So check that our console will be updated here, and it will show that value 17. Now we are again redirecting to the loop L1 instruction. So check that our counter is equal to 02. After executing this instruction, it will become 01. So it will be decremented by counter is equal to 0, 1. And next, we are again redirecting to the L1 label. Now, our next instruction is pop dx instruction. So, what will be the value that is pointed by our stack? That is 0002. So, after executing this instruction, your 0002 value will be coming to your dx register. So, previously, our dx is equal to 0037 and it will be updated here 0002. Again, we have to print this value on your console. That's why we have to add here 30H into our DL register. So where our instruction is add DL comma 30H. So now your DL becomes 32H, and with the help of this two statement, that is move H comma 02H, that is our DOS interrupt, and with the help of this integer 21H interrupt, this value will be updated in our console, and our console will be printed our output, that is 172. Now again we are redirecting to the loop L1 instruction, and after executing this instruction, check that previously the contents are Cx is equal to 0001. After executing this loop L1 instruction, it will become Cx is equal to 0000. So here check that our control will be redirect to the next line of our loop L1. It is not again redirecting to the L1 label. Why? Because our counter value is equal to 0000. This loop instruction will check that if our counter is equal to 00, it will be redirect to the next line of our code. But if it is not equal to 00, then it will be redirect to the label. And here our counter becomes 00. So it will not going with the label L1. It will redirect to the termination of our program. And here with the help of this two line, that is move h comma 4ch and integer 21h, we are ending our program, we are terminating our program, and our program will be executed successfully. So here in this program, we have converted our hexadecimal value, that is ACH, into our BCD number, that is our BCD number is 172. So in this video, we have learned the concept of how we are converting hexadecimal to BCD number and how this will be updated the register value in our emulator.